And go.
All right, so I'm doing a review of the catalytic reduction of carbon dioxide using organoaluminum and gallium compounds. So the kind of overarching idea of the reaction is to use a metal complex, in which case they used aluminum and gallium in this case, with a psyllium ion to catalyze this carbon dioxide reacting with the triethyl silane here to produce this product over here. So normally this had been done using dihydrogen or hydrogen silanes for quite some time, but they were trying to find a group that worked better for this, so they decided, hey, let's try metal group, main group metal ions. And so that's kind of what they did here. So a lot like we've been doing, this has a couple different parts to it. So this is like the first part where they actually take and form the metal complex. So they took an aryl complex, a 2,6 aryl C6H3 lithium compound, and you can add it to a diethyl metal chloride, and then the hope is you end up forming one of these products. In this case, they used aluminum and gallium in place of these products. So, in which case, recently learned this, the other side of the reaction here is where they are adding the metal to that dodeca, like, substituted aluminum, this thing. They're adding this complex to this, is what they ended up doing. Alright, so that sort of thing. Alright, so they kind of just were doing a couple different tests and things, and after they did it, they figured out that the aluminum had ended up working best because it the reaction proceeded at least one order better than last time. And mostly that was due to the low basicity of the counterion. That's all I got.
For the, you can go back a couple slides. Okay, go forward one. Oh wait, no, you were right on the back one, sorry. Why are they introducing this ion again? Sorry.
Sorry, because they're trying to catalyze this reaction. So I didn't figure it out exactly why, but I just knew that they were testing different metal complexes with this lithium ion to see which would catalyze this reaction better.
So what was the anion they were using before this big bulky ass thing?
Let's see. They had a couple different ones listed. I just kind of listed. They were using, I think, iodine or bromine in place here with this. So they found that the dodeca chlorinated one was actually.
They were still using a borane one, so the X could be a bunch of different halogens.
Yeah, it could
but the entire anion itself was replacing possibly an iodine or some much smaller counter ion.
Can you repeat that one more time?
Well, so the entire thing has a negative charge, this big boro complex,
yeah.
Right? Is that being used instead of a normal counter ion? Because this is a very exotic counter ion, as opposed to something you would normally see like tetrafluoroborate or hexafluorophosphine or something like that.
I just know that from what I saw that they had just, whatever, they got rid of that piece entirely and were just using the dodeca chlorinated piece.
Okay.
Like I said, I didn't get a chance to really dig into this too much.
Yeah.
It's been rough.
Alrighty, last but not least.